So before starting the session, I want to make some comments on these sessions. Since this is a workshop mode session, a lot of interactions may be required, but not at the time of presentation. So the theoretical sessions are very less in this module, but what I'm going to do is a hands-on training, and you can follow me in your laptop, and I hope most of you have installed SPSS trial version and also save the dataset which I have shared, and we can have an interaction at the end of each statistical test or activities. So there may be some hands-on activity. So at the end of each hands-on activity, we can have an interaction. And as an introduction, I would like to say a few words about SPSS. SPSS means a statistical package for social sciences, and this particular package is used in various fields like management, social science, engineering, public health, medicine, etc. And you all know, apart from SPSS, there are several other statistical packages or softwares are used for statistical tests like Stata or R program, Python, or even Excel. We can do many of the common statistical tests. So if you add some add-ons in Excel. So, but why SPSS is so particular is it is very easy to use, and that is one of the objective of including this session on SPSS and statistical test in this workshop of research methodology. And without the help of statistician, you can do the statistical test. So I'm going to start with this session. So in this session, I'm going to include, so I'm switch off my video because the range is not good. So in this module, so I have planned this this session on SPSS in two modules. The first module, introduction to SPSS and statistical analysis. So in this, the objective of this session is how to import data from Excel to SPSS, how to define variables in SPSS, how to do compute function in SPSS, how to convert a continuous variables into categories or categorical variables, how to do descriptive statistics in SPSS, how to do normality test in SPSS, and how to do parametric test. So these are the things which are included in the first module today. Okay, so I have also included various parametric tests like independent t-test, opaque sample t-test, one-way ANOVA, and repeated measures of ANOVA test. So before going to these particular tests, first you should have the preliminary and the basic fundamental operations which are required to operate SPSS. So that is very, very essential, because you may have collected several data for your research work. So these data is preferably recorded or saved in Excel files. So this Excel file has to be imported into SPSS. So these are the first thing we need to understand. Now, a short description about a statistical package for social science SPSS. It was initially released on 1968, and the latest version is 28th version, which was released on 2021. So let me ask one question. How many of you have installed SPSS in your laptop? Please give your answer in the chat box. At least 75% of participants have installed. And some of you are unable to install the software. Don't worry, you can associate with others, and you together can work out along with me. Okay. I think only 2 or 3 people have difficulty. Others all have installed, isn't it? So I am going to start with this one. So far, you have any doubt so far? If you want, you can unmute and speak for 30 seconds. Because the preliminary things you should understand and you have to follow. Otherwise, you may not able to do the fundamental statistical analysis using this software. So that is why in the beginning, I want to ensure that all of you can follow my class or my steps. Hope there is no interactions. So let me start with the trial version. It opens like this. The windows will open like this. And in SPSS, we usually work from 2 main windows. Okay. When you open the SPSS for working out any type of statistical analysis, there is a data editor window and there is an output viewer window. So what is this data editor window? Data editor window is the window which shows the data. So whatever we upload from the Excel file, see, in the process of research, you may be collecting the data. For example, if you are doing a study to compare 2 interventions, placebo and the drug, isn't it, in 2 different groups. So you are collecting the scores. Suppose, for example, the dependent variable may be fasting blood sugar. So you want to compare the effect of the intervention on fasting blood sugar. And you are comparing 2 groups. So one group is placebo, other one is drug. So you have the dependent variable fasting blood sugar. So you are entering this fasting blood sugar for each. So for example, 30 or 40 samples are there. 40 patients are enrolled. So these 40 people, you are entering the fasting blood sugar, isn't it? So that data which is recorded in Excel file should be imported to SPSS. I will show you how to import it. Okay. So in data editor window, there are 2 views. One is data view, another one is variable. Data view is nothing but it is the real data you enter. For example, blood pressure or fasting blood sugar, etc. These are the real data. And in variable view, you have to you can see the type of variable, what it is, whether it is a nominal variable or nominal data or a ordinal data or a what you call this ratio data or interval data, etc. So we can name the variable in the variable view, and also you can give values for the variables. I will do it for you in the hands-on training. Another window is output viewer. So whatever statistical test you are doing, the result of the statistical data or the analysis will be, we can view in the output viewer. So remember, there are two windows. One is data editor, that is for data, for viewing the data and for the viewing the variables. Another window is output viewer window, where we can see the result of the statistical test. So this is the view of data view. So see, can you see my cursor? So this is a data view. I told you data view, data editor window has two views. One is data view and another one is variable. So here I am showing you a data view. Okay. Now this one is a variable. In the SPSS data editor window, this is a variable. The previous one, this one is the data view and this one is a variable view. So here each variable can be named, name can be given, type can be given, width of the variable, decimals if any, labels, values of these variables, any missing data. So missing data can be identified, alignment, columns, measures, role, etc. All these things can be viewed for each variables. Okay, so that is for variable. Now next one is, as I told, it is output viewer, where you can see the result of the statistical analysis. So here you can see the descriptive data or the descriptive statistics of one data, that is systemic BP before treatment. So the mean, median, variance, standard deviation, range, interquartile range, skewness, kurtosis, etc. So all type of measures of central tendency and measures of dispersions are given in the descriptive. Let me clarify one thing. I am not going to give any basic information about the statistics, and I hope all of you know about descriptive statistics, because I may not get time for discussing all these descriptive. I think Dr. Thomas have already discussed about mean, median, mode, and other measures of dispersion like standard deviation, range, interquartile gain, then what you call as mean, etc. Isn't it? So I'm not going to describe all these things, but whatever is important, I will. And it displays a chart and tables also. So you see the example here, you can see the histogram. So this is the output view. Now there are different types of files in SPSS. So one file is, it is save file. So this saves, so it can save data as a spreadsheet. Okay, as a spreadsheet, and whatever I have shared with you for a data set, that is in the save file. So it is like a spreadsheet. Okay, so that is a data file. Now another file is called as SPV file. So this can be saved as an output file. Okay, so whatever I have shared with you, it consists of save file. Okay, so you can just click on that, SPSS will open in that. Okay, now let us see how to import data from Excel to SPSS. So hope you remember, I have shared two Excel files with you. Let us import that data into SPSS. So the procedure is, you open the file, then take data, then select the file location of Excel file to be opened, preferably in the desktop. Then change the file type as Excel and select the file. Okay, don't worry, I will show you how to do it. And meanwhile, you can also follow me. So select the file location with Excel file to be opened and click OK. So the Excel data is imported to SPSS data editor in the data view. Okay, so let us do it. So this is the variable view. So the previous one is the data view of the imported file. So here we can see age, gender, ethnicity, type of diabetes mellitus, systemic BP before treatment, systemic BP after treatment, then diastolic BP, fasting blood sugar before treatment, fasting blood sugar after treatment, then BME, etc. Okay, so all these data are imported into SPSS. Now let us see, this is the data view. Let us see the variable view. So the variable, each variable is defined in variable. See, age, it is a numeric type. Type is numeric. Width, I will explain everything. Don't worry. So this is the variable view. I will explain all these things. Okay. And it should be served. Okay. So whatever we discuss now, let us see in hands-on training. Okay. So I recommend all of you can follow me. I'm minimizing this window. I'm taking SPSS file. So this is how it is opened. Can everyone follow me? Please respond in chat box. Have you opened the file? Yes. Okay. So this is how it is opened. And I said, this is the data view. This is the data view. And here, now I am going to import data from the Excel file. Let us see. I'm going to take file. I'm opening the file. Open data. I have saved the file here in desktop, module 1. See, you cannot see any Excel file here. You change the file type. So now it is in save mode, save file. So I am changing it into Excel. So now you can see the Excel file, right? Any confusion? Any confusion here? Once again, I will repeat this. File, open, data. I am finding out my data from here. Data set, module 1. So here you can see save file, isn't it? So I can't find any Excel file here. So I am opening Excel here. Now you can see the Excel file, isn't it? Now Excel data to import. Excel data to import. So just double click on that. So this table will come. Give continue. See, the data set is imported to SPSS. Data set is imported to SPSS. So please raise your hand if you have done. Then I can move to next one. Hope this much is completed, everyone. If you find any difficulty, you please tell me. Because these are the very essential thing. Without importing the data into SPSS, you cannot do any statistical test. Yeah, once again, I will explain it. I'm closing this, not saving. I'm not saving the output here also. Let me do once again. So I am opening this one. Yours may be most recent one, 28 SPSS. Mine is very old, SPSS 16. So file, open, data. So I'm finding the Excel file here. This is a folder, module 1. I cannot find any Excel file. I am changing the file type into Excel. Then I can see this Excel data. Double click on this Excel data. This table will come. Just give continue. Hope you got. Hope you got. Ritesh sir, if you can unmute them, it will be better.
So they can unmute themselves, sir.
Okay, okay. So if you find any difficulty, you can ask me now.
Sir, actually, it's not showing last window. It's showing a different one. It's like
What
read Excel file, read Excel file. Then we have changed that to Excel file, and we have I have double clicked it. Then it's showing like a read Excel file. Like that data it's showing on the background. The other Excel that one data view is also there, but final data type is based on all data and can be different from the preview, which is based on the first 200 data rows. The preview displays only the first five. I don't know what it is. So it's not that continue. You have clicked the continue, no?
Yeah,
That
continue.
one is not showing.
Others. Anybody got this one? Imported.
It's a preview, I think. Preview, it's showing like that. So, okay, I will just.
Yeah, you can give okay. See, mine
Okay.
may be having some difference because mine is very old one, isn't it? SPSS
Okay,
16.
now it's
Yours is,
showing like this.
yeah, yours is 28, most recent one. So there may be some differences. Okay, there must be some differences.
Okay.
It may not be almost the same. Okay, so now you got.
Yeah, yes.
Okay, I hope all of you got. Yes, now we have imported the data in Excel into SPSS. Okay, so I just show you the variable view also. You just click on here. This is the data view. You just click on variable view. See, in variable view, age, gender, type of diabetes mellitus, and all these variables are given. Okay, and I will explain all these things: the name, type, width, etc. I will explain it. Don't worry. So I'm just closing this. I will move on to the next activity. So this is a hands-on training for importing data from Excel to SPSS. Now, I am taking little time for this because these are the basic things. Without this, you cannot do any statistical test in SPSS. Okay. Now, next one is how to define variables in SPSS. How to define variables in SPSS. Now, let us see. You have seen the variable view, right? Variable view. So in variable view, you can see the name, type, etc., width, etc. So each one I am going to explain. So these are the items in the variable view. The first one is the name. Okay. So how to name a variable? You may not have named any variable in Excel file, but in SPSS, you have to define each variable in detail. Okay. So the first item is name. So the name of the variable, it should begin with a letter, or it can be a mix of alphabets and numbers, underscore, hyphen, and are allowed while giving names for these variables. space cannot be used. That is very, very essential. You should not keep any space while giving name for the variable. Okay. The first row of Excel is read as variable names by SPSS. Okay. So the name, these things should be considered. What all things? It should begin with a letter, or it can be a mix of alphabet or numbers. We can use underscore, hyphen, or and, but space should not be used. Now the second one is type. In variable view, the second one is type. So type default, by default, it will give type either numeric or string. So most of the data are in numeric because we are giving numbers, isn't it? If we are giving age, age is in numbers, or if you are giving, for example, male or female. So before that, I want to clarify one thing. When you enter data in Excel, if you give the sex of a patient, gender of a patient, you better give in numbers. For example, when you enter data in Excel file, for male 1, for female 2, rather than giving male or female, it is better to give in numbers. Okay, so that when you import Excel file to SPSS, that will be easy. Okay, so the type of variable is by default, it will be numeric, and don't change anything, the type. Now next one is a width. So you need not manipulate anything in the width. By default, it is 8. That is, width means it is the width of the actual entries. Okay, or how many characters are there in the data. So don't do any manipulations in the width. Decimals. Decimals also don't give manipulations in decimals. By default, it will come. And it is not relevant for string data. Only string data means it's the alphabets, whereas numerical data means it is in numbers. Now label is very, very important. So in the name, I have given that there should not be any space, but it is very difficult to understand, or it is very difficult to read without space. So what we can do is, you can elaborate the name in the label session. Okay, so you can label attached to the variable name. More than 8 characters and spaces can be used. Helpful for reminding users the meaning of variable. For example, pre-treatment. When you write a variable as pre-treatment in the name session, you should not give any space. PRE, TRE, TREA, TMENT. So it should be without space. But in label, you can give space. So label is the explanation of the name. So in the label, we can give before treatment with space. Helpful for reminding users of meaning of variable. Label is displayed in the output of analysis. So it is very easy to find out from the output file, output view, if you give the label. Okay. Examples I will give in the hands-on training. Next is the values. Values are very, very important. Very, very important, especially for categorical variable. For example, male and female. So you should give the data are entered as numbers, isn't it? Male 1 and female 2 in Excel file. So when you import data to SPSS, the numericals are there. But in values, you have to give that 1 is equal to male, 2 is equal to female. Understood? So likewise, we can give another one, that is nationality: Indian, Chinese, American. So there are 3 categories. So for Indian, in the data they have given 1, 2, 3. Indian 1 is equal to Indian, 2 is equal to Chinese, 3 is equal to American. Understood? So likewise, the values can be given in this value section. Now columns, it's a width of the variable column, the data view. By default it is age, and don't manipulate the column. There is not required to manipulate anything in the columns. Now missing also, you need not manipulate anything unless there is any missed values in the data. Suppose what happens is, when you collect data, there may be some missing values. Understood? If you collect through a Google form or something, some participants may not fill a particular question, so that will remain as a missing value. So in that case, you can give some codes for to identifying that missing value. So normally that is not required for your studies, postgraduate research programs. These type of missing values are very, very rare. Okay. Now next is alignment. Missing values usually come across with the public health surveys and all. Okay. Now next one is alignment. So you can keep alignment right, left, or center. Then measures, nominal, ordinal, scale. Normally it is for numeric, continuous variable is shown as scale only. Okay. So variables, string type of variable, the default is nominal scale. So don't manipulate measure also. Okay, unless it is very essential. Understood? Then role. So role, I think in my version it is not there, but don't manipulate anything in the role also. But here, what all things are important is the name, label, and the values. So these things should be manipulated according to our need. Now let us see how to define these variables. So I am going to a hands-on session. So I am opening, so you can also follow me. I am opening the SPSS file. I am importing the data, file, open, data. I am finding my folder. The same thing is repeated, which I was shown you later, before. Excel file, data, Excel to import, continue. Okay. So this is the data view. This is the data view, and this is a variable. So what we want is variable. We are defining each variable. So the first variable is age. First variable is age. I'm not going to do any manipulations here in type, width, decimal, but label I am going to give some changes. Age of patient, age of patient. Okay. Now in the values, I am not going to give any values because it is a continuous variable, not a categorical variable. Hope you understand the difference between continuous variable and categorical variable. These are very basic things, and I'm not going to explain all these things. Categorical means categories like nationality, gender, education level. Understood? So categories. Whereas age, hemoglobin, or fasting blood sugar, then systemic BP, all these things are systolic BP, all these things are continuous variables. Okay. So I'm not giving any values here. Everything is as such. I'm not going to manipulate anything. Now next variable is gender. Gender, I'm going to label. Type, width, and decimal I am not going to change. Gender of, sorry, small, gender of patient, gender of patient, and here I am going to give some values. Okay. So in the variable, in the data view, if you see, gender is given as 1, 2, 1, 2. Here, what it indicates, 1 is male and 2 is female. 1 is male and 2 is female. Understood? So I'm going to give that in variable view. I'm going to give values, gender values, value 1. 1 as male, male, give add. So it is added. Now 2, I am giving female, add, then give okay, no other things, only give okay. So here the values are given. See, now the type of DM, type of diabetes mellitus, I'm not going to change type, width or decimal. See, the name is given without space, So here I am giving label, I can give space, type of diabetes mellitus, So this is the explanation. Label is an explanation of the name. So I am giving values for that. Number one is type 1 diabetes mellitus. Type 1 diabetes mellitus. Add. Number 2 is type 2 diabetes mellitus. Add. I give okay. So the values are given for this. These two variables are categorical variable. Understood? Categorical, because two category, male and female. Type of diabetes, 2 categories. Type 1 and type 2. All the other category, all the other variables are continuous variables. See, BP before treatment, BP after treatment, blood sugar before treatment, blood sugar after treatment, BMI, all these are continuous variables. There is no category. So I am not giving anything. So for example, I am giving only, I am labeling only the first 3, age, gender, and type of it. Otherwise, it will take more time. So I am not going to continue. Hope you understand the defining the variables. Please unmute and say, or you can give your feedback in chat box if everyone followed. These are very, very basic thing. All should follow. Hope it is clear to you. At least 2 people have commented in the chat box, and I am assuming everyone has followed. If you have any difficulty, please tell me. Then only I can proceed to the next step. Now, I'm closing this. I'm not saving this. So next is how to do compute function in SPSS. How to do compute function in SPSS. Okay. So what I'm going to do is I'm going to calculate BMI from height and weight. I'm going to calculate BMI, that is body mass index from height and weight. How to do? Okay. So let us see. Shall I give this one PowerPoint, or shall I directly go to hands-on training? Which one you prefer? Which one is suit for you? So first I will show you the PowerPoint. Okay. The same thing which I have given in the slide, I am going to explain in in the hands-on training, but this is for getting more clarity because these are very basic things. Okay, so how to compute? First, you have to click on to the transform compute variable. Next is, hope all of you can see the PowerPoint slide. Shall I make it full screen? Because if I make it full screen again, I have to minimize it. Now give the target variable height square, because you know BMI, the formula is weight divided by height square in meter. Weight in kilograms divided by height square in meter. So first step is we have to find out the square of the height. So you have given weight and height. So first you have to calculate the square of the height. Understood? Then we have to divide the weight by height square. So then only we'll get a BMI. So first step is target variable is height square. So we are typing the, I will explain it in the hands-on training. So first I find out the height square, the data view, I compute it. Next is the target variable is BMI. We are going to find out BMI. Understood? So now I am taking weight, then divided by height square, give OK, we'll get a BMI. Okay. So I am directly going to hands-on training. Open your SPSS. Open your SPSS. Again, the same thing is repeating. File, open, data. So I am going to open a different file. Remember, I am going to open a different file. See, Excel data to compute function. That is a file you need to open. So previously we have opened Excel data to import, isn't it? So now the first one, Excel data to compute function. I am double clicking on this. Continue. So this is in variable view. I am taking the data view. All of you got? Please respond. All of you got? At least in chat box, or you can unmute and say yes. That will be better for me to understand whether you are following or not. Hope you follow this. Yes. Okay. Now, what I'm going to do is, see, we have the variables like age, gender, height, weight, other variables are there. So I am going to compute. Okay. So transform. So first one is transform compute variable. Once again, I will take, click transform compute variable. So what is the target variable? The first one is height square. So the name I am giving without space, HTSQ. That means height square. And click type and label. So I want to know what it is. Understood? I have given only short form. So I am giving a label here. HEIGHT, height square. That is for my understanding. And this is a numeric data. Continue. Then I am shifting this one to numeric expression. Okay. Before that, so height square, we are going to calculate height square, isn't it? So height, I am clicking here, I am shifting height into. So this is the into mark in SPSS. Into again height. So height into height square. Hope all of you follow. Give OK. So in output file, dataset name, compute height square. You take the dataset. See, a new variable has come, isn't it? Height square. All of you got a new variable height square? Please respond. Yes. Okay. So you get a new variable height square. Now what I'm going to do is we want to find out the BMI, isn't it? So again, the same thing is repeating. Transform, compute variable. So here, this one, the old one is there. So I am resetting this. Click on the reset. Everything will be reset. Now the target variable, what we want is BMI. Label it as body mass index. Body mass index. It's a numeric data. Continue. Okay. Now how to calculate BMI? It is weight divided by, see, this is the division, divided by the new variable which we created is height square, isn't it? Weight divided by height square. So that is BMI. I'm giving OK. Now take the data view. All of you got BMI. See, this is the new data BMI. Yes. So hope you got. Most of you got. So this is how you are computing a new variable from the existing variable. Now you calculate the BMI of all the patients, isn't it? From their height and weight in the SPSS. Okay. So this is about the. So I am saving this. File because we need to categorize it. Okay. Yes. I am giving a name new. So I'm closing everything. We go to next one. So whatever we explain is a computing a new variable. Now how to convert a continuous variable in categories. So now we have created BMI. We have calculated, we have computed BMI variable. Now what I am going to do is we are converting the BMI into BMI categories. All of you know that based on BMI, we can classify underweight, normal weight, overweight, and obese. Understood? So we are classifying the BMI into 4 categories. Understood? So a continuous variable is converted into categorical variable. Understood? Sometimes in the research, we may require to convert a continuous variable into categorical variable. So let us see how to do the conversion. So here, record into different variables, transform, record into different variables. Now numerical variable is BMI. Output variable is BMI categories. I am going little fast. Give values to the categories. When I do hands-on training, please be careful, because this converting a continuous variable to categorical variable is little confusing. So please be attentive. Okay. So I'm not going to give all these slides. Directly, I'm going to give slides. Okay. So I have saved a data set here. See, we have created a new BMI, isn't it? New variable BMI. I am going to open that. See, this is the data set. All of you open this one. Which we have created just now. Please respond. Or you are closed without saving. Yeah. So we have created a new variable BMI. Now this is a continuous variable. This is a continuous variable, isn't it? So we are going to convert this continuous variable into categorical variable. So before that, let us define this variable new one. It's already defined, isn't it? It's already defined. Height square, body mass index. Now let us see the data view. So the first one is transform. To convert a continuous variable to categorical variable, first one, transform record into different variable. See, there are two things: record into same variable, record into different variable. What is the difference? See, when I click this one, record into same variable, then after converting this continuous variable to categorical variable, this continuous variable BMI will not be there. Instead of that, the categorical variable will be there. Categories will be there. So that is, we are just changing one variable to another one. See, when you take this function, record into different variable, both BMI and BMI categories we can see in the data set. So that is the difference. Okay. So I'm taking the second one, record into different variable. I'm clicking on this. So this window will come. All of you got this window. Hope all of you got this window. Okay. Record into different variable. So what is the input variable? Input variable is body mass index. So I am clicking here and I am shifting. Okay. Now I want to define the output variable. So numerical variable is changed into output variable. See, here it is the given, the name and label. So name, always remember, name should be without space. So I am giving BMI CAT, BMI categories. So label, I can explain it. BMI categories. Understood? So name, there should not be any space. Label, you can have space. Now change it. See, in this column, BMI to BMI BMI categories. Now let us give values for this. So BMI is a continuous variable you are going to categorize, isn't it? So old and new values should be given. Understood? So how the BMI is classified? So you know that from the literature. From the literature, less than 18.5 is underweight. So how to do that? Less than 18.5. So I am giving values. So you have to take this one. Okay. Range, lowest through, that is less than that. Okay. 18.5. I am giving 1. So this is the old value. This is a new value. So old value 18.5. That is less than 18.5. Lowest true value. Lowest true value. Less than 18.5. The new value which I am giving is 1. Okay. Then I am adding this. Now next one is, that is a range 18.5. Oh, sorry, 18.6 to 22.9. So I am giving the range here. So this is the less than that range, lowest value through. So now I have to give the range. So range here I have to give, that is 18.6 to 22.9. So that is a range for normal weight. Okay. So the value I am going to give is 2. Now add. Okay. Now next category is again a range, that is starting from 23 to 24.9. Okay, that is taken from the literature. Now the value I am going to give is 3. Adding this. Now next one is above 25. Above 25. So above 25 I am going to give here. Understood? Range value through highest. So 25. 25 is given. 4, value 4, then add. Okay. So I have changed the old value to new category and given as 1, 2, 3, 4. Now continue. Okay. Now I have changed the numerical variable to output variable. I have given the name BMI cat. Explanation is BMI categories. Then I have given old and new values 1 to 4. Then give OK. Okay. Now let us see the data view. When I see the data view, see, there is another new one, new category, new variable. It is categorical variable, categorical variable. All of you got this one? BMI cat as a new variable. Please respond. Either by unmute or Dr. Anne Mary has raised the hand. Any
Can you please explain this once again?
Yeah, we'll do it once again. So transform, record into different variable. See why different variable? When I do different variable, record to different variable, I got both, isn't it? BMI as well as BMI category. If I do this one, record into same variable, I cannot see BMI. Instead of BMI categories, that is new variable will be here. Okay. So I am recording this, record. I am resetting this. Now the first, see already my thing is there. I don't know how to change. Okay, so input variable body mass index. So far, is it okay? BMI category. I am giving BMI categories change. Oh, the variable name duplicates an existing variable name.
This up to this step is okay, sir. Next step onwards.
I will do. BMI classification. I am giving a new name. Okay. BMI classification. Okay. BMI classification. So this is a new variable. Okay. BMI into BMI classification. The same thing, old and this step is okay for you. Giving old value and new value.
Yeah, after this,
See,
it's okay.
less than 18.5. So I am taking range lowest value through value. So less than 18.5. Less than 18.5. I am giving 1. Adding this. Next one is the range. Okay. So range, I am not this one. This range should be taken 18.6 to what I have given 18.6 to 22.9. Okay, value given is 2. Value given is 2. Now next is also a range, that is 23 to 24.9. I am giving 3. And now next one is above 25. So I am giving this one range value through highest. So 25. See, if it is less than that value, then range lowest through should be given, or if it is more than any value, range value through highest, that should be given. So that is 4. This much is over for you. Is it clear? All of you can follow this
Sir,
to this
yes, sir.
up to this. Okay. So continue. Okay. That's all. Then you give all okay. Then you give okay. Take the data view. See, BMI classification, BMI class. Got it?
Okay, sir. Okay, fine.
Hope all of you got it, isn't it? So I am recording a new variable to another, a continuous variable to a categorical value. Now let us see variable view. This is data view. Now change to variable view. Let us see. We have to give values. Otherwise, how you identify new value 1 is underweight or new value 2 is normal weight. So for that, you have to give values. So don't change name, type, width, decimal, label already given. Now values you need to change because it is a categorical value. Understood? So BMI cat, I am giving value. So already we have given 1, 2, 3, 4. Understood? Now we need to label it. We have never labeled anywhere. Understood? So 1 is what? 1 is what? Please respond. 1 is, what is 1? 1 is underweight, isn't it? 1 is underweight, isn't it? That is less than 18.5. PM is less than 18.5. We are given value 1. Now 2, what is the range? What is that? Normal, isn't it? Normal. Now 3 is overweight, isn't it? IGHT, overweight. Now 4, that is more than 25. More than 25. BMI more than 25 is obese. Now give okay. So when you're working out these things, this will come. Okay. Whether it is normal, overweight, or underweight, etc. So I have given, I have defined the new variable BMI category. Understood? So this activity is over. I am closing this. I'm closing this one. I'm not going to save it also. Okay. So changing recording is over. Now next we are going to. So this is the preliminary activities in the SPSS. So how to import the Excel file to SPSS file, how to define variables, how to compute variables, how to change a continuous variable to categorical variable, etc. So these are the basic functions. Now let us see the statistics. Okay. So type of statistics, descriptive statistics are there, then inferential statistics are there. All these things are explained by Dr. Thomas in detail. So I am not going to do everything. So first one I am going to demonstrate is descriptive statistics. So in that, measures of central tendency and measures of variability. Ritesh sir, how long I can take?
Sir, 9:30 is okay.
9:30. So let me do one thing. I will do up to normality test. Okay.
Okay, sir.
The remaining parametric and non-parametric I will continue in next class. Otherwise,
Okay.
it is because these basic functions required some time.
Okay. Okay, sir.
They may not understand.
Okay.
So types of statistics. The first one is descriptive statistics. So how to do descriptive statistics in SPSS? Okay. So hope you all know different types of descriptive statistics and what is the purpose of doing a descriptive statistics. See, when you do inferential statistics, what is the purpose, what is the aim, or what is the objective? Whether the change is significant or not. That is what we are going to conclude finally in the inferential statistics. What is the purpose of descriptive statistics? To find out any wrong entries or any outlier. Have a basic knowledge about sample and targeted variables in the study. Okay, so you will get a broad idea about the sample which we are going to study. When you analyze the descriptive statistics, when you see the mean, or when you see the mode, or when you see the range, or whatever it may be, standard deviation. So you will get a broad idea about your samples, and you can able to summarize the data. Okay, so these are the basic purpose of descriptive statistics. Now let us see how to do descriptive statistics, how to find out. So with a one click, you can find out everything. You need not calculate mean or mode or standard deviation. See, you might have studied the formula to find out standard deviation. You might have studied the formula to find out the standard error of mean, isn't it? All these things, interquartile ranges. So no need to memorize all these formulas, but with the help of SPSS, we can, with one click, you can find out everything. Okay, so shall I go to the slide, or can I do hands-on training? Which one is better?
Sir, hands-on training is better.
That is better, right? Okay.
Yeah.
So let me open this one, SPSS file. So all of you can follow me. Just open SPSS file. The same thing is repeating. Open it. Data. Desktop. Module 1. File type Excel. So this file you open, Excel data to import. I just open it. So all of you have opened data view. Please respond. So you can unmute and see if you're finding difficulty in typing. All of you open the data view. I am waiting for your response. At least one or two can respond. Okay. So the first one is analyze. Analyze descriptive statistics. Follow. Analyze descriptive statistics frequencies. Okay. Frequency. So whatever variables you want to have a descriptive statistics, you can enter age. I'm not going to enter this categorical variable. Gender and type of diabetes mellitus, I'm not going to add. All the other continuous variables I am going to enter. Hope you have done this. Next is go to statistics. So whatever you want, central tendency, dispersion, distribution, percentile values, everything is there in the statistics. So I am going to give mean, median, mode. These are the important measures of central tendency. Now, if you want measures of dispersion, standard deviation, standard error of mean, minimum, maximum, etc. And if you want to know skewness and kurtosis, that also can be viewed. Skewness and kurtosis. So hope you understand the meaning of skewness and kurtosis. Okay. And yeah, that is enough. All of you got this one, this table? Then give continue. Okay. Next is chart. So I am going to histogram also. There is a purpose for that. So in that with the normal curve. Okay. So I will give explanation for this, why we have to give normal curve. Continue. Format. Nothing should be manipulated here. Just give continue and give OK. So this is the output view. This is the output view. See the statistics, descriptive statistics. All of you got this one? Output view. Please respond. All of you can access to output view. Yes. So in this descriptive statistics, n is a sample size. So 40 is a sample. There is no missing data, zero missing data. Mean is given. Standard error of mean. Yes.
So can you explain these steps once again, because I didn't get this.
You want to demonstrate it again?
Once again.
Okay. Yeah. I'll do it. So I am not going to save it. Analyze descriptive statistics frequency. So I am just resetting this. So all the continuous variables I am going to enter. Age, except gender and type of diabetes mellitus, because that is a categorical variable. BMI. Okay. So everything is included. Now in the statistics, what all things you required? Measures of central tendency, mean, medium, mode. Okay. Now measures of dispersion, standard deviation, standard error of mean, minimum value, maximum value. Okay. And if you want skewness and kurtosis. This much you have done.
Yes, sir. Yes.
Proceed. Yeah. So now continue. Now next one is chart. In the chart, I am going to give histograms with normal curve. So both should be clicked. Histograms with normal curve. Give continue. Okay. In the format, nothing should be manipulated. Just give continue. This much is over. This much is over.
Yes, yes, sir.
Yes. Now give just okay. Have you got output view? Output view, descriptive statistics, number of sample, mean, standard error of mean, mode, standard deviation, skewness, standard error of skewness, kurtosis, standard error of kurtosis, minimum value, maximum value. So these are the basic descriptive data from your data set. Okay. So you may find some changes from me because mine is very old one. SPSS 16. Yours is 28, isn't it? There may be some changes, but that doesn't matter. All of you got? All of you got?
Participants, please respond to the faculty's.
Because this is a hands-on
Message.
training, so that I want to ensure that you followed. Otherwise, it is a waste of time. Understood?
Participants, please don't wait for others to answer. You yourself unmute and give response. Okay.
Now this is the descriptive statistics, and let me see. These are the frequency that is not required right now. And let us see the histogram. See what it is. What it is. You may have some basic idea about this one, isn't it? Please respond what it is. This. It is a normal curve, isn't it? It is a normal curve. So age corresponds to normal distribution. So this is histogram is one of the tool for estimating normality. Understood? So this is a normal curve. Now let us see this one. Systolic BP before treatment. This also somewhat it is normal curve. Let us see this one, systolic BP after treatment. This also somewhat it is a normal curve. There are some outliers. Okay. So if you omit this outlier, it will be perfectly normal. And this also we can consider it as a normal. But let us see this one. What it is, what happened to this? What is this called? What is this called? Dr. Thomas has explained this one, isn't it? It is skewed, isn't it? The data is skewed. It is positively skewed. Now let us see the BMI. BMI is also not a normal one. It's not seems to be normal one, and it is like a certain kurtosis also is there. So this is how the descriptive statistics is estimated in SPSS with one touch. So what it is? Have to go to analyze descriptive frequency. In that, statistics central tendency, dispersion, distribution. Okay. Then in chart, you give histograms with a normal curve. Continue. You will get an output view. In the output view, we can see the descriptive statistics, including mean, standard error of mean, mode, standard deviation, skewness, kurtosis, minimum value and maximum value, and also the histograms. Hope you are clear about this. Shall I move to next one? Shall I move to next one? Okay. So I'm closing this. I'm not saving. Okay. So I am skipping this one, descriptive statistics for association between two categorical. This I will take while taking chi-square test. Okay. I'm not going to explain it now. Now, the last one, today's last topic is normality test. Okay. I will do it very fast. So I'm not going to give your this one slide. See, normality. What do you mean by normality? Can anybody say? What do you mean by normality? What do you understand by the concept normality? So for doing any parametric test, the data should be normal, should be normally distributed, isn't it? So why I'm asking this one is you should have a basic idea about this. So it is a normal curve or normal distribution is otherwise known as Gaussian distribution. Okay, and it's a type of continuous probability distribution for statistics, and that is very essential for parametric test. So the data, the variables should be, the data should be normally distributed. That is one of the criteria for parametric test. Okay. Now there are different ways for calculating the normal distribution. So what are the ways for calculating normality? The normality can be estimated with a, right now I have shown you, right? Normal curve. If it corresponds to the normal curve, then we can assume that the data is normally distributed. Another thing is when you see the skewness and kurtosis. Skewness and kurtosis, if it is positively skewed, for example, let me show one example for that. See, this is symmetrical distribution, normal distribution, and this is positively skewed, and this is negatively skewed. The data which is given is negatively skewed. So, for doing any parametric test, the data should be having a symmetrical distribution, normal distribution. Okay. Similarly, the peak of the curve. So this is positive kurtosis, and this is normal distribution. So the peak is high, and this can be because of any extreme values or outlier in the data. So if you avoid such outlier, we can make it a normal curve. Okay, and this is negative kurtosis. So for a parametric test to do, the data should be normally distributed. So before deciding which test should be given, the test of significance, for the selection of test of significance, we must do the normality test. Okay, so what all normality tests we are doing? So as I said, histogram. With the help of histogram, we can analyze or we can estimate whether the data is normally distributed or not. With the help of skewness and kurtosis, we'll come to know that whether the data is normally distributed or not. Then another one important test is called as, there are two tests for that: Kolmogorov-Smirnov test and Shaparov-Wills test. Okay, so I am going to demonstrate you how to do Kolmogorov-Smirnov. In short, we can say KS test or Shaparov-Wills test. So normally Normally, I follow Shapirovil's test because that is more appropriate for a small sample. Kolmogorov-Smirnov test is mostly a large samples. When you go for a public health survey or something, we can go for that. Otherwise, for almost all the experimental tests or clinical trials, we can go for a Shapirovil's test. Okay. So the null hypothesis for this test is the data are normally distributed. The null hypothesis is normally data is normally distributed, and if the significant value of Shapirovil's test is more than 0.05. See, the difference between the test of significance and test of assumption is, so when you do any parametric test or a non-parametric test, you are doing test of significance. So if the test of significance is significant, the p-value is less than 0.05 or 0.01. Okay. But test of assumptions, see, these type of normality test, then variance test, 11 is variance test, and then what you call this homoscedasticity test. All these things test are test of assumptions. These test of assumptions, the p-value should be more than 0.05. Then only it will be significant. Okay. So that is the difference between test of significance and test of assumptions. So now let us see Kolmogorov-Smirnov test and Shapirovil's test, how to do it. Okay. So I'm going to open the SPSS file. Open data.
So your screen is not visible.
My screen is not visible. Let me see. Now it is okay. Is it visible now?
Oh,
Yes,
okay,
sir.
okay.
So I'm opening the SPSS file. File open. Just do it fast. Desktop. What do you want? SPSS Excel data to import. So same thing is repeating. Now I got the data set here. Let us see the normality. Analyze. Descriptive. Let me see. Yes. See. First you have to go to analyze, descriptive, then explore. So what all things you need to find out the normality, age. I am skipping the categorical variables here. I am taking only 2 variables. Okay. Only 3 variables I am taking: age, systolic BP before treatment, body mass index. Okay. One more I will take. No, I will take all these things. Some may be not normally distributed. Okay. So I have added all these dependent variable here. Statistics, descriptive, all the descriptive, confidence interval for me 95%. Continue, then plots. So in the plot, I'm not giving stem and plot, stem and leaf, only histogram. Only histogram I'm giving. See, normality plot with test. Normality plot with test. Click on this. Continue. Options. Don't change anything in the option. Just give continuous. Then display both statistics and plot. Okay. Both I clicked. Okay. All of you can follow this. See, in the output file, so we have given descriptive, isn't it? We are given the descriptive. So all the descriptive data is available starting from mean to kurtosis. All the descriptive data is there for all the variables. So what our interest is the normality test, isn't it? See, the normality test for normality. I told you Kolmogorov, Smirnov test and Shapirovi's test. Kolmogorov, Smirnov test and Shapirov test. I am considering. See, people may some people may consider Smirnov test. Some people may consider Shapirovi's test. So I am following Shapirovi's test and see the significant. See, in SPSS, p-value is significant. SIG, significance, isn't it? This is a p-value. See the p-value 0.849, age 0.849. Whether it is normally distributed or not. Please answer. The p-value significance is 0.849 for age, whether it is normally distributed or not. Please respond. I'll finish it fast. Don't worry. This is the last activity. And this is more than 0.05, isn't it? More than 0.05. So it is normally distributed. It is normally distributed. Age is normally distributed. See systolic BP before treatment 0.564. So that is also more than 0.05. So that is also significant. So this is also normally distributed. See here, the p-value is 0.183 is more than 0.05. So BMI also normally distributed. See, systolic BP after treatment 0.731, that is more than 0.05. So that is significant. So it is normally distributed. See, fasting blood pressure, fasting blood sugar before treatment. So this is less than 0.0001. Understood? So it is less than 0.05. So it is this variable, this data is not normally distributed. Not normally distributed because it is less than 0.05. Now let us see fasting blood sugar after treatment. Again, it is 0.001. So it is less than 0.05, which is more than 0.001. So it is significant and it is the data is not normally distributed. So apart from this one, fasting blood sugar before treatment and after treatment, all the other variables, all the other data are normally distributed. Okay. So I have shown you the histograms, isn't it? See, age is perfectly normal curve. See, another method of finding out the normality is QQ plot or quantile plot. See, it is almost, the data is almost adjacent to the this line, and there is only a slight outlier. Is understood? So this is another way of estimating the normality. Okay, there are 4 methods. One is skewness and kurtosis, KS test and Shapirovitz's test, histogram, QQ plot. See, these are the 4 methods for finding out the normality. Okay. So this I already explained this one. So among this, which one is better? Which one is most robust one? Nothing but the test of normality. That too, Shapirovitz's test. Okay. Any doubt in this?
Sir, actually, when the p-value is less than 0.05, then we used to say it's significant.
That is the difference. That is the difference I told you. There is a difference in p-value in the test of significance and test of assumption. This test of normality is a test of assumption, and it is significant when it is more than 0.05. But in case of test of significance, the parametric test, T test, high score test, അല്ലെങ്കിൽ ഏതെങ്കിലും ഒരു parametric or non-parametric test. If it is less than 0.05, then that is significant. Understood? So when you, any doubt?
Okay. But the p-value is the same p-value, or like for test of normality for the same study we will get another p-value.
Yeah, but if you test for normality, if the data is normally distributed, you will get the p-value more than 0.05. And if you test significant, any test of significance, if you do, if there is a significant change before and after, or we compare two groups, the change is significant, then in that case you will get a p-value less than 0.05. See, only thing you must remember is for test of significance. And the test of significance normally all the statistical analysis, parametric and non-parametric, chi-square test, t-test, paired t-test, or Kruskal-Wallis test, or Mann-Whitney t-test. All these tests, the significant, when it becomes significant, if it is less than 0.05. And test of normality, then test of variance. Another one is test of, I will come to that when you explain about ANOVA. Okay, test of variance, or test of this one. What is it? Homogeneity. Then another thing is I forgot the name of that. Okay. So all these things, the p-value should be more than 0.05. Then only it becomes significant. Understood? So otherwise, all the test of significance, it should be less than 0.05. P-value should be less than 0.05. Then only it becomes significant. Hope you understand.
Yes, yes.
Clear level.
Clear.
Okay. So I am stopping right now here, and we'll continue with the inferential statistics parametric test in next class. Okay. So this is the more important thing in your dissertation or your research, parametric and non-parametric test. Okay. So if possible, you can do your own exercise with the data set. Your trial version will be valid for 1 month, 28 days. So you can do any type of exercise in that. Okay. Ritesh sir, shall I conclude?
Okay, sir. Okay, sir. Okay, thank you, Dr. Ramji sir, for a wonderful session. It was a really wonderful learning experience from you, sir. Hope